Hello. I'm going to be talking about JS engines, or TS engines. Here are some reasons to listen to what I'm saying. I'm the creator of Porffor, which we'll get into later. Who here has heard of WinterCG before? Nice. I'm impressed. But yeah, I'm the co-chair of that, so I'm one of the people running that, hopefully standardizing things, especially web interoperability things between runtimes. And then also I'm a member of TC39 as an invited expert. So how do JS engines work? The simplest form you have is interpretation, where it's very simple, in which you just have a main loop running your JavaScript. The only downside to that is the performance is not great. So people invented just-in-time compilers instead. So V8 is probably the most famous example. It's the JS engine of Node, Chrome, used in like 1,000 other things. So how a JS engine works is, instead of just having one main loop in your program, it will take your JS, and once it's run enough times, compile that into machine code and then execute that instead, which can result in, like, I think, depending on what you're doing, like 100 times speed up, because there's no overhead of a loop. It's as if it was something like C. So yeah, JIT can be very good, since, well, I mean, one of the main trade-offs is the longer you spend compiling it, it runs faster, but then also if a user's loading a website, they have to wait for that compile time, which is why most engines have several tiers, which it can be great for performance, but bad for complexity. Like, I think V8 has 4 different JIT compilers now, just for the trade-off of that initial startup time and then how fast it's run. And security is a complex topic, which is better nowadays, but the result of compiling unknown code on a user's machine can be sketchy. So ahead of time compilation. So if you've used C++ or Rust or many languages like that, these will compile ahead of time, which is where you have some program like Clang or GCC or Rust C or anything like that, where you give them your code ahead of time and they make a binary. So it could be WebAssembly to run on the website, or a native binary like to run on Windows or Linux. So these are great for that, but this doesn't exist for JavaScript. And you might think, oh, just take the machine code, which the JIT compiler's already done, and just use that. But for many complex reasons, as I won't get into, it's basically unusable outside the JS engine. Like, you could probably get it to work, but not well. So the good side of ahead of time is you don't have the loading time because it's already compiled by the developer, and there's no security implication, because if it's, say, WebAssembly that's running in a sandbox, and you're not compiling on the user's device, so you're not just running random machine code, even if it is compiled by hopefully something secure. So you might be thinking, why doesn't it exist for JavaScript? And I guess it's been theorized a lot, but no one's ever really done it well for a variety of reasons. But what I'll be talking about today is Porffor, which is this, at least hopefully. So yeah, so Porffor is, it takes in JavaScript input, and then it makes a binary, like WebAssembly or a native thing you can just run on your machine. And yeah, to go into this, Test262 is the official test suite from ECMAScript, where it tests essentially every single language feature, like regex or modules or anything in the language. And I've been testing it since basically month 2 of the project. And it's up to 47% now, passing the entire suite, which when it started, it was more like 5. But yeah, and you may notice a correlation here. Does anyone want to shout out a guess what this correlation is, of why it's gone up so recently? Just shout if you have a guess. Yeah, funding. Who knew funding open source makes it better? Yeah, and you may wonder about performance. So in one benchmark I like to do this is comparing Dino and Bun's compile options, which is basically where they bundle their entire runtime with something. So the main advantage here is memory usage because you're not spinning up like an entire JIT engine or runtime. And so instead of having like 50 megabytes, you have one. And then the actual time it takes to run is also much better because it's basically, you know what code is to be written. And the other benefit is the native compilation. So here is Dino and Buns, where they're like 90 something megabytes, because that's the entirety of the JS runtime. Like, even if you don't use stuff like internationalization, they still have all that data in there. No, Dino's been doing some stuff recently where they can opt that stuff out, but I think the lowest I've seen is still like 40. So I want to shout a guess as to Porffor's size for the Hello World. Just one. It's 15 kilobytes, which I think is a... Yeah, it's not like a realistic example, but it's just to show the possibility that we can just not have to have entire JS runtimes for small things. Anyway, this is a TypeScript meetup. But the good thing is, because we control the JS engine, we can just let it support TypeScript. No TSC, no transpiler. You can just take in TypeScript as if it was JavaScript, which is great for that. But you may be thinking, like, why? Why would I do that instead of just transpiling it? And the good thing is, we can use that to optimize because we have that input. So we have all the type annotations or type defs or anything. So we can use that data and information to actually optimize. Because traditionally, JIT engines, whilst compiling, because they're doing it at runtime, they can just log every single type of every single variable or argument. So they can basically take a good guess as to, oh, this function is called with a number like 1,000 times. It will probably be called a number the next time. But the problem is, because it's ahead of time, we can't do this because we're compiling before. So we haven't run the code, we don't know what it's going to do. And you can infer some types, which you might think makes TypeScript necessary for this, but for some cases, it can just be useless. Like, especially if you're exporting something, you have no idea what the user is going to run with that. Hopefully the types you said, but without type checking. Yeah, so for a basic demo, here is the WebAssembly output, which I'll get into in a minute. But for just adding two things, if we kill the optimization it usually does, it has all this WebAssembly and about 700 bytes. So to go into this in a bit. So this is just setting up the two variables with their values and the different types. And then all this code is basically just saying, are these strings? Like, should I do a string concatenation or a number add? Then this is actually doing the concatenation. Then this is actually doing the add. So if you have type annotations, you can make it 100 bytes instead of 700 because you know they have to be numbers. So you just get a massive size win. Which can help, because there are some concerns with ahead of time compilation where even if you make it fast, you might have to have all that unnecessary code, but TypeScript or inferring types essentially alleviates that entire concern. And yeah, the WebAssembly for that is literally just, here are two variables, add them. But yeah, the problem with this currently is Porffor does not type check because that's not what the project is. I don't want to get into that. So currently, if you give it bad types, it will just behave extremely unexpected or crash. So the future could be where you have a fast path and a slow path, checking if things are as expected before. And another future is if you have a range of types, like this, you have no idea what type this will be at compile time. But you know it'll be a string or a number. So instead of just optimizing based on one type, you could optimize based on a range of types, which is common for a lot of things. Like if you have an addition, it could be a string or a number. So that can be helpful in larger complex code. And yeah, one thing JITs are very good at is objects. Since they have that information at runtime, they make shapes in memory where, say like it's the TypeScript compiler with like syntax tree. So they have basically the exact same structure every time. So they can optimize it internally. The problem with this at compile time, you don't really know. But with TypeScript types, you could probably use that information and get the same win. And I will do a demo after getting some water. Any questions?
Would you like to set up for the demo first? I can.
That's fine. I think it should be set up.
All right. If there are any questions, okay, I saw a hand go swiftly up over here.
Thank you. Hello, hello. Thank you for the presentation. It was actually really interesting. So I guess my question right now is, when do you believe it's going to be ready for being used in production?
Yeah. That's a good question. I guess it's a question of when it's ready to be used and when it's ready, like when it's good. I think in terms of like conformance, where it can run the JavaScript you want, my hope is next year. Probably, hopefully earlier than later. But essentially right now I'm spending almost all of my effort on conformance, making more JavaScript work instead of optimizations, because it's no good having something fast if it doesn't work. So yeah, my hope is next year at some point.
All right, do you want to proceed with the demo?
Yes. So this is just a REPL, like Node or something. Well, oh yeah, it says running on Node.js because the project itself is written in JavaScript. For better or for worse. So you can do anything you could do in a normal REPL. Add numbers, the date API, or like JSON even works. So you could, hopefully you should be able to do anything you can usually in this kind of basic demo. Then there's also aspects like native compilation where here's just like a basic hello world. And then you can compile it with a command like this. Waiting for Clang. And then it runs. Yeah, my favorite bit about this is it's 40 kilobytes when it's JavaScript, which like is impossible usually. Oh, I was testing on Linux. Windows is bad for file sizes at least.
Give Oliver time.
Yeah, and there's some stuff like mixing types does work. And then running this with TypeScript as an example of the unexpected behavior. So this is not valid, obviously. If I yes, so this is obviously invalid, but I don't type check, so instead of crashing, it is a pointer. Which is, I mean, it's kind of interesting because you can do things which should be impossible in JS, like when you have the power of, you can do anything in the engine. With something like this, you could just change a string in memory if you wanted some super fast optimization. So, for better or for worse, anything people want me to try in the REPL?
Inline WebAssembly.
Yeah, so thanks to WebAssembly, you can do essentially anything inline, which is very cursed. No, it does not like new lines. Anything else people want to try? I do have basic async support, where, like for example, like, oh, so this is a promise, and you can't await because top level away JavaScript. But yeah, and you can also then works. So there's like a very basic event loop, which is usable for this, but if you want like async IO, this is definitely not good enough for it. No, that is one of the main big things left to do, hopefully before the end of this year, where there's no garbage collection yet, which when I started this project, it was before Wasm GC was usable. So my hope is to have two modes of you can use Wasm GC or my own garbage collector, because if you're running, say, embedded on the device, Wasm GC doesn't make much sense as it probably isn't supported. But if you're running in the browser, Wasm GC makes total sense. Any other questions?
We need to get the questions on the recording via the mic.
Is Porffor WinterCG compliant?
No. That's my entire answer. Is anything? No. But I mean, I have some things which are in the WinterCG spec, and then also there's some stuff like fetch, which, no. I maybe one day, but.
I'm sorry if this might be far in the future, but I see quite a lot of potential here, especially running natively, to finally allow a bit more concurrent programming and multi-threading in JavaScript. Have you given any thought to that and about what potential this might unlock, or what kind of paradigms you could adopt to make that possible?
Yeah, I'm definitely interested in that. I haven't experimented much yet, but I have, if I get up my own blog post, I have done FFI natively, which has been very good, like this. So you can see here there's FFI, which if you don't know is essentially you can call into other libraries of C. And I think someone benchmarked it, and it was 2% slower than native C. I think the same thing with V8 was like 10%. So it has no overhead because it's basically just C calling over C, which can be very good for native performance.
On your compliance graph, you mentioned something like 55%. Does this 55% include Express.js to be able to run, to compile and run?
No, it doesn't include like Node.js compatibility. So anything using like Node APIs wouldn't work. Like Node HTTP wouldn't be a thing.
Yeah, and one follow-up. So it's run only JavaScript, which has no dependencies external, or they also could be compiled.
Yeah, self-hosting is definitely very interesting. I have one dependency, which is a JS parser, but aside from that, I have no others. So it could, in theory, compile itself, which is very interesting.
Thank you.
I was about to ask if, since before it's written in JS, it means it can compile itself. But you already answered that.
What purpose do you envision for this project? So, for example, V8 and GSC and SpiderMonkey are all browser JavaScript engines. Is it more like a tool for building executables, or do you envision embedding this in a browser or something like that?
Yeah, I guess there's many use cases, especially some I didn't consider when starting it. You can definitely compile to WebAssembly and use it in the browser, which is good, but I don't think that will replace just doing normal JS. There are some very interesting ones like, say, like edge networks running on the edge. Instead of, usually, if you're doing WebAssembly currently, you have to embed an interpreter in that WebAssembly. So not only is it like 20 megabytes, I think I benchmarked my engine versus them, and it was like 50 times faster because they're running an interpreter in WebAssembly. So, yeah.
Yeah, this looks great. I had a couple of questions. One, how does it compare to AssemblyScript, which had been around for a while, but looks like it kind of lost momentum a little bit? And since we're at TypeScript Meetup, why did you write in JavaScript and not TypeScript?
Two good questions. AssemblyScript, I think AssemblyScript is very interesting. I didn't know it existed when I first started this, but I think it's very good. I think there's different names. Like for me, I especially want normal JS and TypeScript. Like I don't think the engine should limit what you're doing. Even if it is slow, it should definitely work. And it's like, there is some TypeScript in the project. Like all the built-in APIs, like promise or date, that's all in TypeScript, because the optimizations I showed earlier allows it to run sometimes several times faster. But the actual core compiler itself is in JavaScript, mostly just so it can run in basically any place.
I think that's it for questions. Oh, one here, sorry.
As you said that you don't have any type checking in there at this point of time, but do you think in the future when you add type checking, the time of executing will increase? And how would it compare later on at the stage?
I think type checking is probably out of scope. My idea for now at least is you have TSC or something type checking, then you also compile with this. There's like two separate things to try and like alleviate the scope of the project.
Anchor is, because it's a really interesting project, what do you think is the biggest challenge for you today?
I think probably coming up garbage collection, which not really, like I think it's definitely doable. It's just more like finding the right approach because there's so many different options to do. And I just think, I think also seeing seeing new languages like Zig or Gleam or something, the ecosystem needs to be there. So there's no point just having a JS engine because people expect nowadays like a linter or anything else to go with that. So I think getting it over the hurdle where it's like actually good to use, like as fun as something like Dino or Bun, will be a challenge, but I think it's definitely doable.
Last thing, how many people are contributing to this particular project?
I guess mostly me, but I have some people doing PRs, which is very nice.
What's the best way to follow the project?
Too many slides. You can watch the website, which has that graph I showed earlier, live as commits go in, or follow me on Twitter at CanadaHonk, where I tweet as I do new features.